All right, guys, section 1.12, part 3, we're going to apply our 4 transformations to a table of values today. We're only going to do one example, but I'm going to show you guys 2 different ways to do this, and you get to pick if you like the first option better or the second option better. So let's say we have a function, g of x. So g of x is given by this table of values here, and f of x is a series of transformations on g of x. All right, so our question that we're looking for is finding f of 3. So the first method I'm going to show you guys is instead of thinking about transformations, we're just going to plug in 3 for the x's, and we're just going to simplify this and end up at the answer. All right, this is a way that I personally do these. So let's see what that looks like. All right, so I'm going to plug in 3 for the x's here. So we still have negative 3 times g of 1/2, or there was an x, now there's a 3, and then we have plus 2. Okay, same equation here, just plugged in 3 for both x's. Now, to evaluate this or to simplify this, because x is gone, I'm just going to start on the insidemost parentheses and kind of work my way out from there. Like we would if we're simplifying any kind of expression, if we're following order of operations. We're going to start on the insidemost part. And so I'm going to subtract the 1 and the 3, or the 1 from the 3, I should say. So 3 minus 1 gives us 2, so I'm going to replace that with a 2. The next step here would be to multiply these two numbers, right? They're still in parentheses and they're multiplications. I'm going to multiply 1/2 with 2. And if we multiply 2 by 1/2, it just gives us 1. And there's 2 ways you could think about that, right? First off, just 1/2 of 2 is 1. But if we wanted them to both be fractions, we multiply the top to get, or the tops to get 2, multiply the bottoms to get 2, and 2 divided by 2 is 1. Now, the next step, we need to actually figure out what g of 1 is. So I ignore that negative 3 for now. We're just going to figure out what g of 1 is from the table. All right, so in the table, when x is 1, g of x is negative 9. So we're going to replace g of 1 with negative 9. And now all we have to do is multiply and add. So if I multiply those two, I get 27. And if I add the 2 to it, I get 29. All right, so that was the answer to that one. We're going to get the same answer here. So we're going to get 29 at the end, hopefully. I did this problem earlier and got a completely wrong value. But I know why I missed it. I just messed up one small thing. So we're going to get 29 at the end, but I want to show you guys a second way to think about this. You do not have to do this method. Some people will just prefer this over just plugging in the number and simplifying like I did here. All right, so finding f of 3, instead of plugging in, I'm going to just use or do these 4 transformations to the table of values. All right, so I'm going to start with the 2 that are on the outside. So we've got a times negative 3 and a plus 2. Times negative 3 and a plus 2. And we know anything outside changes the y values or the g of x values. So I'm going to go through and multiply all of these by negative 3. Multiply all of them by negative 3. And then it says that we can add 2, right? So we multiply the y's by negative 3, and then we add 2 to all the y's to move it up. So add 2 all the way down. Add 2, add 2, add 2, and add 2. All right, so if we do that, so we multiply first, and then we add, so that would give us negative 15 plus 2. So that's negative 13. This would give us negative 18 plus 2. So negative 16. This would give us positive 24 plus 2, give us 26. This one gives us, let's see, that's going to be 27 plus 2, so 29. And then this gives us negative 30 plus 2, negative 28. All right, so that's what our new y values are going to be. The originals are right here, but we're multiplying them all by negative 3 and adding 2. Now I'm going to do the 2 transformations to the x values. And again, we should go from left to right, still on the inside here. So I'm going to times everything, not by 1/2, but by its reciprocal of 2. And this moves the graph right 1, which would actually add 1 to the x's. Not, even though it's a minus 1, it's opposite. So I'm going to multiply all the x's by 2, and then we're going to add 1 to all the x's. All right, so again, all these x's we're going to do times 2 plus 1 times 2 plus 1 all the way down. So multiply them by 2 and then add 1. And if we did that, well, that gives us negative 4 plus 1, so negative 3. That's negative 2 plus 1, which would give us negative 1, rather, not negative 2. Negative 1. So 0 times 2 is 0, plus 1 is 1. This gives us 2 plus 1, which is 3, and then 4 plus 1, which is 5. Okay, so what we've done now is we've created a new table, and this is no longer x and g of x. Now this is a table for f of x. All right, and we're using our new x coordinates and our new y coordinates over here. So now how do we figure out f of 3? Well, we go to when x is 3 in the table, and our f of x value there is 29. And so that's our answer, which is what we got on the last part. So again, it really just comes down to, would you rather do the 2 transformations to the y values and the 2 to the x values? Or do you want to plug in the number and just simplify algebraically here? All right, so that's it for this. There will be a part 4. That's pretty tricky, so it'll be, if I give you an easier question on your next test, it'll be normal. I'm going to expect everyone to do it, but some of the tricky ones will be probably extra credit on our next test. All right, but that's it for this one. Stay flawless.